All right, I'm also going to try this fantastic thing with Google Slide that lets you have closed caption in case I just get overexcited and I talk too quickly and you have no idea what I'm saying, so you can also see it live. And also it makes some funny mistakes you can just have fun at spotting. Okay, cool. So I'm going to be telling you about the brain imaging data structure. So when we organize this session, we want to have like two approaches. Like we wanted to have like Adeline will give you sort of the big like overview of data management. Sort of like the top-down approach, but we also wanted to have some sort of like bottom-up approach, like, okay, what is it in practice when you're in neuroscience and you want to organize your data and sort of try to follow best practices? And so that's why it sort of felt appropriate to talk about BIDS, because this is pretty much sort of becoming the emerging standard on how to organize your data. So, okay, first, just two things about me. I'm just a biologist by training, and I guess over the years I've developed a mild case of like subclinical file naming OCD. So if you show me your computer and then your files are not properly named, then I get a bit aggravated. Nothing bad. I deal with it, but that's just where I'm coming from. So I'm not like that's where I'm coming from, just so that you know. And I've also, just to sort of point out that many of the things I'm going to be talking about come from my personal experience of like making mistakes, and I just want to avoid you making the same mistakes again. Right, so first of all, so I would like to sort of figure out who you are. So there should be a link in this in the document that I have given you. And it's just to figure out quickly if you are a PhD student, a postdoc, and so on and so forth. So I think you should get a link to a poll where you can click on who you are and what type of data you use. So just to sort of know, to get an idea quickly of what people are in the crowd at the moment. I think we've got about 30 people. So and on the next slide, you can also answer which type of data you use, and you can click several responses on that one, right? Just to sort of get an idea of what you deal with sort of every day. Also because the brain imaging data structure really just can cover some of the things listed here, but not all of them, or it will be able to deal with some of them soon. And just to sort of know what kind of what are your needs basically. I'm really curious also to see when people say other, I think I'll be interested in the discussion afterwards to figure out what other includes. Because it's really interesting to see what other, like what further needs there are in the community, so we can sort of improve the standards that that BIDS is trying to be. All right, so quickly, it seems we have mostly PhD students. And okay, I see a lot of people doing MRI and fMRI. MRI and fMRI MRI can be just like diffusion MRI, can be ASL. It's a very broadly speaking, if you use, or just anatomical in any sort of like shape or form. Okay, and I see that a lot of you do behavioral testing on computers, a lot of like pen and paper as well, some motion tracking. Okay, cool, good. So that gives me a bit of an idea of what crowd we are today, is around today. Okay, cool. All right, so let me continue. I want to sort of, okay, so what seems to be the problem? Like, so you publish an article, but I'm going to take the point of view, a pretty radical point of view for some, that an article about computational result is advertising. It is not scholarship. The actual scholarship is actually the full software environment, the code and the data that produce the results. So, I mean, the Clearout and Donahoe just took that point of view I think in the 90s, and they started just being very, very aggressively transparent with the way they did their work. And that was before like pretty much the internet and that we have today, right? So it was clearly harder to do back then, clearly easier to do today, but still we're not quite yet there. So what seems to be the problem? The current state, and that's from a paper that's actually 9 years old, so it should be updated, is that when it comes to MRI research, for example, I couldn't find any data for EEG. They went through like a reviewed literature. They got about 22,000 fMRI related publications in the 20 years that fMRI has been around. And they computed like with some conservative estimate of the number of subjects and how much it costs per hour. They estimated that they've got a total cost of MRI data has been acquired around like 43 million US dollars, right? But actually, when you look online, what's actually available, there's only like less than a few % of that that's just out there, right? So there's clearly a lot of money that's being wasted by not sharing data. Because you've not extracted all the information from a data set. At least maybe even if you think you have, maybe some other people could do something with that data set, right? But actually, the problem is a bit worse than that. So here, there's a tweet from Adina Wagner, who is working on a software. So she's part of a team working on a software to help with data curation. And she just said, like, sometimes I think back at the time when I asked data for authors for data, if you want to sort of reproduce some of their results. And after months, you got a single raw data.mat file with an undocumented like 6,000 dimensional MATLAB structure and sort of a can't help with interpretation, sorry, as a like message to go with that. Which actually I replied, well, you got some data back, so that's better than the average, which is actually the case. A lot of the time when actually people go and ask around for data, the email is not valid anymore, or you never get an answer, and so on and so forth. But then she explained, well, I definitely had to sort of chase 8 people for like 2 or 3 months, and then I got the equivalent of, okay, that's like a command line, and if you actually type that in a terminal on a computer, it will just create a file with just random stuff in it, and that's completely hard to just like, you cannot do anything with it. And she was saying that, some of the variable names were just completely not transparent, and there was no connection to anything in the paper. So it's not just a problem that we not sharing enough data, is that the way we actually organize our data is so poor that even if we shared it, no one would be able to reuse it. All right. What do we tell ourselves most of the time when we actually run a study is that, oh, wait, I will sort and clean this data or the code that goes with it right before we submit, or for sure once we have this published. And to this, I just have to say, oh, my sweet summer child, this will never happen. No one does that. And the people who actually, the few people who actually do that, I still have to meet one, to be honest. Right? To me, that sounds a bit like someone saying, yes, I only clean my teeth right before I go to the dentist appointment. Well, that's not how good data hygiene works. It's just like your general like dental hygiene. You just do it regularly, right? Okay, and so yeah, so in general we tend to rush a little bit because things we want to spend time on as researchers, we want to answer our scientific questions, right? We don't want to spend time on like figuring how the data set should be organized, organizing the data set, rewriting the code because we have changed something in the way the data is structured, or we don't have, we don't want to spend time digging into our data to write our methods section, right? So because we're mostly interested in answering our scientific question, we sort of skip all those sort of things and we rush, right? And sometimes we have good excuses, right? I mean, like, we have constraints in the real world. I have a grant proposal to write, a grant report to write. So we ask our students to just like give us some results very quickly. Or as a student, we have a PhD to finish and we want to move on to something else in our life. So we just like, just rush to the results. But today, I sort of, what would you think of a heart surgeon who would just not scrub properly his hands before entering an operation theater because, he wants to just like save the patient? Well, you might just think that at least that's slightly a bit unprofessional. So, I just want to sort of maybe rushing might not be the way to go about this. All right. I know it sounds a bit crazy that I'm going to say that, but I'm not here to guilt trip you. So the idea is that, very often when people like see maybe my data or my like code or walk even into my house, they say, oh, and I just use this how I don't look at the mess. And they go like, what are you talking about? Everything is super tidy. And like, there's like a pile of paper that's not alphabetically organized on my table and I feel bad about this, right? So this is not the message I want to tell. This is not how, like, I'm not trying to guilt trip you into cleaning your data so you can share them with others. What I'm here to tell you is more, I want you to clean your data so you make it easier to share them with your closest collaborator, who happens to be yourself in 6 months. I think like Adeline was saying before, is like the person who's gonna like benefit the most from just good data management is yourself. Yeah, just like, make a present to your future self and just try to sort of like, try to follow some of these things. And a couple of like rule of thumbs you can sort of have about whether you're doing bad or good. I'm going to take two concepts that actually come from software development. The first one is called the bus factor of a project, and sort of ask yourself, if you were hit by a bus, can one of your lab mates resume your research where you left off with less than a week delay? Meaning that, is there enough documentation? Are things well organized enough that, they can pick up where you left off fairly quickly? And the other concept is the concept of technical debt. So the idea when you rush because you skip some steps that are actually essential in the long term, then you're gonna need to take time in the future to pay back all those steps you skipped, right? So technical debt is the idea you're taking a time loan from future you, and you will have to pay that debt back. And like any debt, it comes with interests, and you're not going to like the interest rate because it's really going to slow you down in the long term, right? So these are sort of concepts you might want to keep in mind when you're organizing your data, and want to know whether you're doing a good job, right? Keeping in mind that, it's not just about, trying to share your data from a purely altruistic point of view. It's just, maybe you can do it, maybe you can organize your data just out of like pure self-interest. Okay, so let's jump in and talk about BIDS. BIDS stands for Brain Imaging Data Structure, and it is not a file format, right? It has some constraints on which type of file format you can include in it, but it's not in itself a file format. It's more about how you organize your different files, how you organize your data and the metadata. And Adeline was telling you about the FAIR principle. That stands for findable, accessible, interpretable, and reusable. And BIDS is much more about the two later aspects of it, right? So you want to try to organize your data so that it is interoperable and reusable by other people. All right. So a couple of just quick definitions, because if you start using BIDS, you're going to hear those words being thrown around a lot. And so just so that you know what people refer to. So usually you have different type of data in a project, and you've got what's called like the source data, the raw data, and the derivatives. Source data, let's try to just quickly describe this as what comes out of the device that you've used to just do the recording, whether it's an MRI scanner, whether it's in like EEG, whether you're doing MEG, or whether it's like, you've just programmed a behavioral experiment and you just get some files out of that, right? So that would be the source data. Raw data is what BIDS is mostly about. So that's when you take your data from the source, from what came out of the device, and you try to organize it in a structured fashion that's really highly standardized. And then you have derivatives data, which is the stuff that is being produced by your analysis of your raw data, right? So, and derivatives can get to finer and finer level of summarizing your data, just like with the most the final most derivative data would be just like, the table you put in your journal article, right? So BIDS is mostly about raw data, but it covers part of the derivatives, and this should be expanding in the coming, I would say, years, definitely. All right, so BIDS is the Marie Kondo of data curation. If you don't know Marie Kondo, she's this Japanese woman who's had a show on Netflix on how to sort of, she goes into people's home and helps them just declutter their house and help them organize everything. So clearly, if you want to share your data, your MRI data as just a bunch of messy, poorly named DICOM files, you could potentially do it, but that's clearly not going to spark joy. And if you use a BIDS data structure, clearly it's going to make a lot of people much happier. So what are the different things covered by BIDS? So you've got MRI, whether it's anatomical, fMRI, diffusion weighted imaging. It also covers EEG, IEG, and MEG as well. And you can also organize associated behavioral data, physiological and genetic data that go with all of those. And you can also use just behavioral data to a certain extent, just as a standalone as well. Okay, and soon you will BIDS is also extending, so you should be able to organize like PET data, more complex type of MRI data, near-infrared spectroscopy. Eye tracking is partly supported already, so there's a way you could, like the BIDS format and the BIDS standard is, so the BIDS structure is flexible enough that it can already accommodate for you to just like organize your eye tracking data like this, but it doesn't capture a lot of the metadata that goes with this. There's motion tracking in the pipeline that should be coming, people working on that. A whole bunch of different derivatives will be there. You can also even start organizing how you specify some of your analysis in a GLM for MRI, for example. And you've got a whole list of BIDS extension proposals, or as they are called, in case you're wondering whether something like you have a specific need and you want to know whether it's coming, you can always go and check what are the work in progress on those documents and on those different extensions. Right, so I'm just going to quickly run you through like some of the very big concepts that you might encounter when you have to deal with a BIDS data set. First of all, so as I was saying, you can have all your data with the source data, the raw and the derivatives. And so within the raw data, which is the BIDS usually data set proper, everything is organized hierarchically with just subject, one folder for each subject. And within that, you can have different sessions, meaning that it could be data acquired on a different day, or you can sort of group together a certain type of experiment in a session. And then after that, within each session, you have a folder for each recorded modality, right? So for anatomical data, for like MRI anatomical data, for behavioral, for diffusion weighted imaging, EEG, functional, meaning like the fMRI, IEG or MEG, for example. So each modality would have its own folder where the data is organized in there. And it comes, and BIDS comes with sort of strict rules, I would say, on how to organize the metadata and the tabular data. So in general, the recommendation, not the recommendation, like the way you must organize your metadata is try to follow a few principles. For example, it should be independent of the programming language you might use to analyze your data, right? So it cannot be like a .mat file. Even if you use MATLAB, in the end, you're going to have to save your tabular data and metadata in a format that's not specific to MATLAB. The format should be human and machine readable. So you don't want something that's a binary file that's only a machine will be able to read, but not a human. And similarly, you don't want something that's pretty much like a method section that a human can read, but a machine cannot parse easily, right? And you want something, and so at the end, you also want a format that's easily open with like any text editor on any computer, right? Okay. And there are, so the two main type of metadata and tabular data you're going to find in there are called JSON files and TSV files. So JSON file stands for JavaScript Object Notation. You might not, most likely you've never heard of that because that's more people dealing with computer science who usually are familiar with this. And just so that you know where they come from, they're usually a format used by websites when they talk to one another. They just send, very often they will just communicate through packing information into these JSON files and they send them to each other, right? And in the BIDS, we use them to store pairs of an attribute with a certain value. Sounds a bit abstract, but I'll give you an example right after that. And TSV files for any kind of table data, and TSV stands for tabulation separated tabulation separated values, right? So pretty much a TSV file you can open in any sort of spreadsheet software. So that's like you can, like on any computer, you can open that without any problem. Okay, and how is the data organized? I'm going to give you a few examples, but I'm not going to go through the whole list of how the files are named for each modality, because otherwise we're going to be here for like just way too long. And usually I know that in practice, it's only by sort of starting having to organize your data as a BIDS data set that you learn the best way about this. But I can already sort of tell you a couple of things, so that every name is organized with like a field and a given label. So they work by pairs, right? And many of those like pairs are actually facultative, so you don't have to use them if you don't need them, right? And I put them in like in square brackets here. So all files will have to have like the subject and the label of the subject. If you have used sessions, then you will have to specify session as well. And then I'm going to jump to the very end of where you have a modality label added to the file. In this case, could be like if you're using an anatomical MRI, it could be it's a T1 weighted image, for example. And you can have, and they use the Nifty format. So that's like for MRI, that's what we use. For EEG and MEG, you have different formats allowed depending on what your device gives you. So you will have to go and check in the specification whether your format is supported, but it's been designed so that it can support a wide variety of formats. And for each file, it's also it comes together with a JSON file, which is where the metadata about this data is actually stored. Right? So here I'm just giving you an example about anatomical data and functional data. And functional also has all these extra things. So for example, you will have for functional data, you will have to specify which task you actually ran and which task corresponds to this data set. And you have all these other things that allow you to sort of add more, like to distinguish between different, for example, type of acquisition or different type of like contrast enhancement and some other things. Not going to go in too much into the details because I can just get very confusing. If you have several runs of the same task, you just have a run and then indicate the number. And then the type of contrast that was used for your functional data, whether like bold or it's like CBV, and there's a couple of others that you can list. And once again, that data comes with its own JSON file that stores all the metadata about this this file. So this looks like very long names, but in practice, when you open a data set, very often, very few data set actually use like all of those fields. And in practice, it looks a bit smaller, just like this, for example. So you have an anatomical folder, and this is a T1 weighted image from subject 1, session 1, and this is the JSON file that goes with it. And for the functional data, for example, it's the same subject, same session. The task is called like viz motion, so you don't necessarily know what that is. And it's bold data. If you want to know what the task is, you might actually get more description in the JSON file that goes with it. And because it's a task and you want to sort of know when subject responded to a certain stimulus, it also comes with a TSV file that's like a table that says, okay, at this time in the experiment, this thing happened. And you can then use that for all the information in your analysis later on. Okay, I'm just going to quickly give you an example, like show you where you can get examples of BIDS datasets. So that link should also be in the file that I sent you. So if you go to this website, so it's on GitHub. So a lot of the information for BIDS is organized in this BIDS organization called like BIDS standards. And one of the repository that I have is called BIDS examples. And this is just a list of datasets. A long list of data sets. And if you go at the bottom, you keep scrolling down, you get a description of what are the modalities that you can find in there. So whether it's MRI, MEG, EEG, and so on and so forth. Also corresponding here, if you will be the link to get the actual data. So what I mean by this is that if you actually try to download this, there we go. All right, and downloading. Yes, there we go. So that's done. I've downloaded all the data that was here. That's only 25 megabytes. And the reason for that is that they've actually purged the data. Each data file has been purged from its actual content. So now it's just like an empty vessel that has the name but nothing in it. But it's really useful when you want to actually sort of get an idea of what other data set look like. So I actually have it here on my hard drive. So you can open any of those and start browsing. It's like, okay, here we have a 7 Tesla data set, and each subject is organized with 2 sessions with anatomical data. FMAP is for a field map. That's for functional data. And on session 2, it's pretty much the same, except that you don't have anatomical data, right? So you can, I really recommend that if you're a bit confused about how to organize your data, just go and have a look at those examples. That might help you figure out how things should look like. And that can really help you get started. Okay, let's go back to this. Yeah, maybe, wait, before I switch, actually, there are a couple other things maybe I should mention. So each file is also going to come with some things that must be in there. So there you will have a dataset description JSON file that you should be able to open in any just editor, which is the minimal would be like which is the version of the BIDS that you've used and the name of the dataset. But it has a lot of recommended fields as well, including, for example, what type of license, as Adeline was mentioned. So there's a lot of more information you can add to those data sets and to that structure so that you know how to, people know what to do with it and how to cite it, for example. You have a participants TSV file, which is pretty much a listing of the participants and some of their characteristics. Anything else I should maybe mention? No, I think I'll stop there. Otherwise, you're going to get very confused because you can go into a lot of details about this. Yeah, I'm going to stop there on that one because let's move on. Okay. How are we doing in time? Okay, I have a few more minutes. I should be able to continue. All right. All right. And so that's the BIDS sort of data set. That's still the very big overview of how to sort of organize your data. But BIDS is a bit more than just a data structure. So it is clearly what's now we're sort of starting to call an ecosystem around it. And the people behind the BIDS organization in general are have this sort of philosophy around it that, you know, that goes around those three principles. In general, you want to minimize complexity and facilitate adoption of the BIDS standard. They try to follow what's called like the Pareto principle. So where you try to tackle 80% of the most common use in the community. So if you have a very, very sort of like specific niche need, okay, we can try to accommodate, but you might not be like, you know, the main target for BIDS. But I just want to mention that BIDS is still fairly flexible and allows you to do a lot of things, even given the constraint given by the standard. And the third principle of I would say the BIDS philosophy is that it's community driven. So we want to try to develop the standard by getting input from the community and also to make sure that it is actually adopted by the community in general. Like there's no point trying to develop a standard if no one is going to use it. And it's usually, and the whole like BIDS organization is revolve around three pillars: the BIDS standard, which includes so the specification. Okay, I'm going to jump there again. I'm switching website all the time. I'm sorry. The BIDS specification is just almost this really formal document describing how you should organize your data. And it is not fun to read. Well, unless you're a bit of a weirdo like me, and then you might actually just find it interesting. But otherwise, it's not a page turner that is going to keep you awake at night. So usually if you have to go and use a specification, I would tell you just go and search directly for something, like you want to know something about EEG. It will just highlight the different parts that are related to your query, and you can just jump directly there. It's very like no one just reads this thing from like the first page to the end. Okay, next thing is what's called the BIDS validator. So that's a very handy tool that you can use to know whether once you've organized your data, it actually complies with the rules of how a BIDS data set should be organized. And the way it works is that you just point the validator to a data set. We can try to make it run on actually one of the data sets that are in the examples. And you click upload. Okay, it says upload, but it will not actually upload any data, and it will, so there's no like privacy issue there. It will just do some very sort of light query of the metadata and the structure of your folder to know whether it's actually organized the proper way. And it will give you feedback on how things, whether you're complying with the way it should be organized or not. It will give you errors. So for example, here it's telling you, okay, we've got a problem, your files are empty. Well, it's normal. I've pointed it to an example that comes from the BIDS example. And as I told you, there are empty files. So this is normal. You should expect that for this data set, for example. And it can also give you warning and say, hey, there are a few things that, yeah, it's fine by the BIDS, but you might want to check those out. There might be something wrong there, right? Or it might tell you, hey, actually, you're missing you might want to add some description, what's called like a data dictionary to your tabular data. So you've got this spreadsheet data, but you have no way of explaining to someone who wants to use them what each column corresponds to, right? So you can create a small JSON file that's like a data dictionary that says, hey, column 1 has this name and it contains this type of data. So that would be sort of the next part of the the BIDS standard. So it really helps you sort of organize your data, and the specification tell you how to organize it, and BIDS validator tell you whether you've done a good job at following the specification. BIDS example is the sort of third part of the BIDS standard because it's really helpful for people to have examples of just how to do things. Okay. And then you have, okay, the BIDS, yeah, BIDS tools. All right, so that's the next sort of pillar. And that's anything, pretty much any kind of software, broadly speaking, that is related to using BIDS. The main one, I guess, you're going to be interested in is the converters. And there's a whole like series of them. I've put a link in the document that I shared with you. And the purpose of these converters is to go from the source data, like, something that comes from your fMRI, from your computer, from your EEG recording device or whatever, and to convert that into a standard BIDS data set, like to have the raw data that's like organized properly. And I think that as Adeline was saying before, you don't want to do that manually. You're going to make mistakes. So that's why converters were created, so that you can do that. You can script that, and it can like automatically format your data in a BIDS data set. Next thing that's part of the BIDS tools are what's called the BIDS apps. So the idea is that it's like, just think about it as a little package that knows that your data is organized as a BIDS data set, and will be able to completely automatically analyze your data set because it's been organized as a BIDS data set. That's a bit of the beauty of BIDS, is that you're going to gain time in the long run as well, because the computer or software knows where to look for all the information because you follow the specification, right? I just want to mention a few of them here. The first one is BIDSonym, which is a very simple app to anonymize your data set. It's mostly targeted towards MRI, and I guess, as you might know, just sharing MRI data is not trivial because there's some privacy issues. So BIDSonym will just sort of what we call deface the data set. We'll remove the face from the MRI scan so that the people cannot be re-identified that way. And we also sort of look through the metadata that might be in your data set to make sure you've not left things like patient name or an address or anything like this that just should not be in there if you want to make sure your data set is as anonymous as possible. Two other BIDS app I want to mention would be MRI QC, which is a fully automated pipeline for doing quality control of your MRI data set for anatomical or functional data. And the last one is fMRI Prep, which is once again a fully automated pre-processing pipeline for fMRI. So I know if you're doing EEG, MEG, you might go, yeah, well, there's not a lot of stuff for me there. It's coming. I know that people are working on those. It's just that the BIDS was mostly at first designed by the MRI community, and now it's growing. So I think the tools are coming, but there's a bit of a lag. Another simple reason why you might just want to organize some of your data as BIDS is that even the main software that we use in neuroscience already offers some support to interact with the BIDS dataset. So SPM does that, AFNI to a certain extent. And this week there was a conference on EEG, MEG, and there were a few of the software developers, and I think most of them mentioned that there is some support for a BIDS dataset in the dataset that they have. And finally, even if you're not using one of the big data sets, there are tools that exist to help you sort of interact with the data set, like BIDS or BIDS MATLAB. So even if you're like, you have to script your own things, but you have to sort of interact with the BIDS data sets, that will help you sort of organize your script and sort of queries, like know how many subjects you have, know what modalities. It really helps just save you time not having to recode some of that, like those very low level like bits of code that you would need to just work every day with a BIDS data set. Oh, okay. And finally, the BIDS collaboration, the last pillar, I would say, of the BIDS organization. It's really, BIDS is more than just, it's just more than a data structure. It's also like a community, and that's really just trying to help each other. So you can usually go either through the mailing list on Google, on the Google group. People are working also on developing the starter kit, which is pretty much the place where you would go to if you like, you don't know anything about BIDS. That's why we try to keep all the, basic information on how to get started. There's also a forum where you can just ask questions. Okay, Neurostar forum is just more general, but you can ask questions about BIDS as well. And in general, if you have questions or you need a not covered, just get in touch. You can ask for improvement or for like enhancements if something you think that this should be in there, and you can contribute. So all the extensions that are work in progress are looking for people to sort of help them design them. It's also a good way to make sure that your needs will be covered by the BIDS standards. Like, so that very early you can say, hey, I'm working with motion tracking data. I want to make sure that the standard that's going to be coming soon will actually just cover my use case. So I'd better get in touch with the people designing this. And then a couple of things to finish on beyond BIDS. Because as I said, BIDS is not, I'm not going to cover the data sharing aspect, because that's not necessarily what BIDS is focused on. But I want to point to a couple of things. First of all, when it comes to privacy of sharing, neuroimaging data, that's a big concern. So especially as Adeline was mentioning, when you start adding GDPR in the mix, things get very complicated. So I want to point out to this other community like led work called Open Brain Consent, where people are trying to create a template of a consent form that would help and facilitate the sharing of data. And I know that in general, they're looking for feedback. So if you start using it and you get in touch with the data protection officer of the university and you get feedback from those, do not hesitate to get back to the people behind the Open Brain Consent project, because they'll be happy to sort of know about how it is being used and if they've missed something. And another thing I want to point out is that very often we have not, we didn't think about having those sharing clause or data sharing clause into the consent form we use nowadays, right? So there's still a way you can sort of share your data, but it's not going to be your raw data. So I have this figure on the right here that says, okay, you can go from like having data sets that include raw data and pre-processed data, and these are like the very big like Connectome project type of data sets. You have website like OpenFMRI where you can just upload your raw data sets in a BIDS format. OpenFMRI though is in the US, so that's a big no-no if you are like us, you're in Europe, so you cannot upload your data there because GDPR. But there are ways you can sort of still share some of your data. I mean, we all do it. When you, in MRI, for example, when you include the peak coordinates of where your activation in the brain was, you are sharing your data. It's just a very, very highly summarized version of your data, but that's what you did. So there's a step in between where you can share statistical maps that are average at the group level and contain no information about any of your participants, because this is group data, but they give you a lot more information to other researchers to sort of use them. So that's definitely something I do encourage you to sort of do. There's a website called NeuroVault where you can do that. And for MRI data, there's a standard that you can use called NIDM results, and it's just a couple of clicks in SPM to export your data that way, and then it can take you less than 5 minutes to just share that kind of data out there. And one final thing that I won't have time to talk about, but if you start dealing with a lot of data, or even just a little bit, I would say you might want to have a look at this software called DataLad, which will help you with data curation on the long term, because it really sort of promotes good, I would say, data management practices and help you have different versions of your data as time goes by, and to sort of easily manage your raw data and your derivatives and so on and so forth. So that's definitely something I would recommend you have a look at. And with that, I am finished, and I would like to thank you for your attention.